All right, all right, well, folks. Welcome to Unit 6. We're going to start this unit with unions and intersections of sets. So basically, think of it mainly as Venn diagrams, but we're going to dive deep into Venn diagrams and yeah, just kind of describe exactly what union and intersections are, plus many other things as well. So skip ahead from the first question, looking at the diagram. So you see the Venn diagram. So elements of set A would all be contained in A. Elements in set B would all be contained in B, but you'll notice that there's an overlap, elements shared between sets A and B. Um, we call that middle part the intersection as well. So just kind of mentioning it right off the bat, the intersection is the overlapped region. The union is the combination of them. So like all of A with all of B. So like all this circles and the stuff in between them. So union is everything here. Intersection would only be the middle between them. And also, if nothing's in A and B, like if there's something that's not in both of them, it would be outside of them. We call that the universal set, anything that's outside A and B. I mean, you'll see that when we start getting into some examples here. So let's solve the following problems. So at a school of 500 students, there are 125 students enrolled in Algebra 2. There are 257 students who play sports and 52 students who are enrolled in Algebra 2 and play sports. So create a Venn diagram to illustrate this information. So Venn diagram, let's get going here. So let's make it, there you go. So, all right, I'm gonna call this A and this one B. Just gonna go ahead and mention, remember, set A is gonna be Algebra 2. Set B is going to be those who play sports. Now, a general word of thumb here, or rule of thumb, is to start with the middle and work your way out. Don't forget as well the universal set on the outside. A lot of people forget that. I almost forgot that, right? Sometimes we'll call this set U. I don't think it's necessarily has to be like that for this problem, but I'm going to do that anyway. All right, so let's start with the overlap. Now, overlap is people who are both in Algebra 2 and play sports, and we see that there are 52 students that are enrolled in Algebra 2 and play sports. So we're going to have 52 right here. Now let's work our way backwards again. So 257 students who play sports. Well, so all of B should add up to 257, but remember, we already have 52 of them already accounted for. So if we already have 52 of the 257, then the remaining just that play sports would be 205, right? 205 plus the 52 makes this 257 in total. So keep in mind, this 257 students who play sports is not exclusive to sports. There is that overlap where, yes, some of the 257 students who play sports are also the ones who are enrolled in Algebra 2. So again, that's the overlap. That's where people tend to make their mistakes. We're going to do the same thing with A. So A, we have 125 students enrolled in Algebra 2. Right, 125 in total, but we already have accounted for 52 of them, right? So 125 in total minus the 52 we've already accounted for, and that leaves us how much? I want to say 73. 73 plus 52 add up to 125. I think it does. So there you go. Right now we're not done entirely yet because how many students have we totally accounted for here? 73. I'm gonna need a calculator for this. Give me a second. So we've accounted for 73 plus 52 plus 205. Let's see here. 73 plus 52 plus 205. We've accounted for 330 so far, but remember there's 500 students in total. which means that there are still 500 minus 330, 170 students left who are not enrolled in Algebra 2 or play sports. So that's the number on the outside, 170 people who are not in either of these. All right, so hopefully that's our first look into Venn diagrams. We're gonna have plenty more practice, but hopefully we're off to a good start there. All right, let's talk about some symbols and some meanings here. And then refer it back to this question. So N of A there, NA, stands for the number of elements in A. That's how you're going to read it. And it kind of says it here, the number of elements in A. So number of elements in A is how many people, how many things are in A. And in this case, as we saw, in A, we have 125 in total, right? So 125 would be the value for this particular problem. Now, this is the intersection symbol, this little arch. So A and B is how we read that, right? A and B. And of course, the N is the number of elements in A and B. So basically it's saying how many are intersecting, how many people are in both A and B. So that's going to be, in this case, the 52, right? A and B is the 52. That's how many elements are there. That's how many people were there. So this problem, it's 52. Now, the next one is A or B. So the upside down arch, this is the U shape. I know it says and they're all the elements that are in one or both of these sets, right? As opposed to the last one, which is elements that are in both sets. The overlap, this one's in one or both. So A or B. So that was in total here, the 330. You add up how many people are in these circles entirely, and it's 330, remember. So in this case, 330. Now, A prime, or sometimes referred to as A complement, sometimes it's, you see like a little C there or something. This means not in A. So how many elements are not in A? So in A, we remember we had 125, but not in A, you can see here, is 375 in total. So for this problem, it would be 375. Keep it looking down. So again, the number of elements in A or B, but not really. So not A or B. So what I like to do when it gets kind of confusing like this and seeing how many, I'm going to zoom in a little bit there, is I like to figure out what is this, and then just do the opposite, essentially is what that symbol means. So A or B, remember, was the 330 here. So if I'm doing not that, then I'm doing this 170, right? So for this one, I would say 170. All right, similarly, we have A and B, but not. So we're going to have the intersection, but it's really everything other than the intersection. So the intersection A and B, remember, is 52. But if we're doing everything that's not the intersection, then it's the 73, 205, and 170, which would add up to 448. And then finally, A and not B. So the intersection of A and not B. So it has to be in A and it has to not be in B. That's only the 73, right? A was 125, but if we're including the parts that's not overlapping with B, then we're not counting the 52. So it's in A and not in B. That's the 73 that we're seeing here. All right, so hopefully, again, this is a kind of a big rodeo we're doing here. So try to keep up, or it always helps you can rewind and watch again. So now we're going to make another Venn diagram to illustrate the following information. We have M, N are the two big sets here. So here we go. We have M. Let me make these a little bigger. So that's M, that's N, and then remember the universal set, the outer part, just to catch anything that's left over. So number of elements in M is 89. Most people would just probably put 89 here, but we can't do that because we don't know how much the 89 is here and how much is here. We know that in total, it's going to be 89, but we need to know the overlap first. Same thing with the N. We know that this will total up to 103, but right now, I don't know until I have more information how much is here, how much of the 103 is here, and how much is here. I know in total, I have 130 combined between them. All right. Now we're going to learn a new formula. I don't think we've mentioned it before. No, I don't see it up there. We're going to learn a formula to help us find this intersection. All right. All right. So hear me out. Let me use the highlighter tool. Where's the highlighter tool? Here's the highlighter tool. All right. So if I take all the elements from this, however much this is, right? You get what I'm saying? We have this. Now we know that overall that's 89, correct? But it says right there, 89. But we just don't know how much is in this region versus this region, right? But okay, we have that, right? Let's say I add that amount to n. If I add these together. So I'm going to add all of n, right? Put it all together, right? I'm going to add up n. Now n was a total of 103. Now, the problem with that is when I add them up, I'm going to have an overlap, right? I'm going to have some values that I've counted twice. Correct? Correct. Okay. So let's add them up first. So if I add them up, 89 plus 103 is 192. Okay? 192. However, so I know that the union here can only have a maximum of 130. So the difference here is how much is in this overlap. So if I can find out what the difference between this number and the amount that's supposed to be in total here, then I'll know how much the overlap contained. So if I take the 192 and I minus the 130 from it, we're going to see that I have 62 in the middle. So 62 is my overlap. Hopefully you were with me there. I added up all of A with all of B, realized that I was 62 over the limit. So that means I've counted that many twice. So hopefully that fits in. Well, let's go ahead and fill in the rest of the space here, and we'll do the math and make sure everything checks out. So M, remember, is a total of 89, but we had 62 here, which means we have 27 left over here to make a total 89. And for N, remember, we have a total of 103, which leaves it, this one would be 41, because 41 plus 62 is 103. And now if we do all the quick math here, you'll notice that M totals up to 89, N totals up to 103, and all together, these three combined add up to 130. Now remember, universal set has to have 178 in total. So where's that extra 58 supposed to be? Or is it 48? Sorry. That extra 48 is sitting out here chilling, right? So now we've added up all four numbers, we get the whole thing of 178 in total. All right. Now there's a formula that goes with this that'll make your life a little bit easier. The formula goes like this. The union. So M union, let me just use the little U. M union N is equal to the number of elements in M plus the number of elements in N, but minus the number of elements in M intersecting N, right? So let me make sure you understand what I'm saying here. So the union of them together, remember, was 130, right? And we can get that number by adding up the total of M, which was 89, plus the total of N, which was 103. Oh my gosh, come on, cooperate here. But subtracting the overlap, because we counted the overlap twice, right? If I count this in total, I'm counting the 27 and 62, but then I count this, I'm counting the 41 and 62. So I'm counting the 62 twice. So we subtract the overlap, we have our equation, right? So this all checks out mathematically. Normally, we'll have 3 of these and we'll be missing 1. Like in this case, we didn't originally have this, right? That's the number that we solved for. But now that we know it, obviously I just kind of plugged it in. You can see it, it all makes sense. It all checks out. But yes, this is the formula. I think it's going to be down here somewhere. Yeah, sort of. They kind of have a little backwards here, but yes, this is it that I was just writing down, except they kind of have it reversed. They have this on the right side and then all of this on the left side. I had it the other way around, but there's your formula. Make sure you get to know this because it's going to be one that we probably will use a little bit quite frequently. And here's the math again that we kind of did over here on the side, but you can kind of see it worked out using the formula. 89 plus 103 minus something equals 130. Well, 89 plus 103 is 192, but minus how much equals 130? Minusing 62, right? 62 is the overlap. So that's how we figured out the overlap was 62. All right. Create a Venn diagram to represent the following information and answer the questions that follow. Okay. All right. So this one's big, right? 150 high school students, 80 have laptops, 110 have cell phones, and 125 have iPods. All right. And then we have both laptop, cell phone, both laptop, iPod, both cell phone, iPod. And we have 50 with all 3. This is a triple Venn diagram. So let's see if we can kind of follow along with me. So triple Venn diagram, we're going to have 1, 2, 3. It's not beautiful, but it's going to work. We have laptops, cell phones, and iPods. So laptop, cell phone, and then iPod. All right. So remember, we're going to have 80 in total for the laptop, but we don't know how much that 80 is broken down. But we know that in total, all of this space here will add up to 80 for laptop. Same thing with cell phones. We know that all of this will add up to 110. And then for iPods, all of this will add up to 125. But remember, I'm going to skip ahead here. The best place to start is the most narrowed place in the center. You start in the center and you can work your way outwards. Okay, so in the middle, how many people have all 3, laptop, cell phone, iPod? There are 50 students that have all 3. So we're going to go ahead, boom, 50. We know that exactly. So now we have 50 less in each one of these, basically, when we get down to it. But we still have other overlap regions to attend to. So for example, you see how it says 98 students have both a cell phone and an iPod? So cell phone and iPod are this little like football shape here. It says 98 students have both, but remember we've already counted 50. So that means right here we'll have 48 more. All right, looking at the next one, 58 have both a laptop and an iPod. So laptop and iPod, that's this football wedge here. Remember, it's 58. We already counted 50 of them. So that means there's 8 more right there that just have laptop and iPod, but not all 3. And then we have one more overlap. 62 students have both a laptop and a cell phone. So laptop and cell phone, this overlap, this football shape should be 62. Again, we've already counted for 50, so this leaves 12 left over. So you see what I mean by working our way in to out. So now let's look at the iPods. I have 125 in total. Well, look how much we've already accounted for with the iPods. We have 58 and 48, which adds up to 106, I want to say. So that's 106, and there's 125 here in total. That leaves 19 people left over with just an iPod, but nothing else. Similarly, keep working our way backwards. 110 have cell phones. So 110 should be the total here. And well, if you do the math, well, if these already added up to 110, so then there's nobody else who has just a cell phone without the other two, because these already add up to the 110. And then we have 80 with laptops. So if you do the math here, we have what seems to add up to 70. So if these add up to 70 and there's 80 in total, then that means there's 10 people left that have just a laptop. So now if you look at it, laptop totals 80, cell phone total is 110, and iPod total is 125. But now we see how everything is broken down versus how many people just have iPod, just laptop, just cell phone, or how many people have laptop and cell phone, how many people have laptop and iPod, et cetera, how many people have all 3, right? How many students have just a cell phone? The answer there is 0. There's 0 people who have just a cell phone. How many students have none of the mentioned items? It's a good point. We forgot to mention that. So the universal set, again, like I said, I tend to forget this from time to time. There's 150 in total. So how many did we already account for here? Right? Because it's 150 in total. So if I add up all these numbers individually, 10 plus 12 plus 8 plus 50 plus 48 plus 19 and plus 0, obviously, but we don't really need that. I have 147. So this all adds up to 147, which means if there's 150, that there's 3 total that don't have any of those, right? So now this whole thing adds up to 150. So 3 people who don't have any of them. How many students have an iPod and laptop, but not a cell phone? So an iPod and a laptop, but not a cell phone is this 8 right here. All right. Boy, there's some more problems here, but I'm wondering how much time I have to work on them. Let's just keep going. If I have to stop, I'm gonna stop. But earlier you asked to find the number of customers that said they only like chocolate, right? That was from this question in the very, very beginning, which I kind of skipped. Said Freezy's ice cream stand polls its customers on their favorite flavor, chocolate or vanilla. 103 customers said they like chocolate, 98 customers said they liked vanilla, while 27 customers said they liked both chocolate and vanilla. How many customers said they liked only chocolate? So that question from earlier, I guess we're coming back to it. So as you saw, we had chocolate, vanilla, and both. It said that there were how many people that liked both? Going back to my notes. There were 27 people that liked both. And there's in total of 98 that liked vanilla. So 98 minus 27 means there's 71 people who are just plain vanilla. And there was 103 that like chocolate. So 103 minus 27 is 76. So how many customers only like chocolate would be the 76. Oh, 72? 76. I wrote 72, but I meant 76. All right. So that just answers that question from earlier. Use the Venn diagram below to determine the number of elements in each set described in the following examples. All right. So number of elements in A. So A, we have to add up all of what's in A, 3, 7, 8, and 8, which totals up to 26. For C, all the elements of C. C is all of these, 12, 4, 8, 8, which adds up to 32. Number 4, elements not in A. So everything outside of A. So here's A, everything that's not that. So 6, 12, 4, and 8, which adds up to 30. And yeah, I guess that answers those. Example 5, A and B, the overlap of A and B. So A and B overlap here. That's 7 and 8. Which of course adds up to 15. A or B or C. So in A or in B or in C. So everything that's being circled here. Don't count anything twice, of course, just all those numbers. So 3, 7, 8, 8, 8, 4, and 12 all added up make 50 when you add it all up together. That's 50. All right, number 7, A and not in C. So it has to be in A, but not in C. Because it's an intersection, A and not C. So it has to be in A, but not in C. So that's going to be the 3 and the 7. So that's going to be a total of 10. A and B and C. So the overlap has to be in A and in B and in C. That's the middle, which is 8. And then finally, not in A and not in B and not in C. So it's not in A, it's not in B, and it's not in C. That's got to be, let me erase that, the 6 out here. There we go. All right. The last part of this is review, which we'll probably just do together in class, just as extra practice. But yeah, I think this helps you at least learning it for today. If you need any extra practice, please make sure you do these problems down here. Do it with us in class. And if you have questions, just let me know. I'll see you guys later in 6.2. Bye for now.